Let's start working on this review sheet, okay? So problem number 1, this review sheet for test 1 goes in the order that we saw it, the material in. So problem 1 is the square root of a negative 275. Well, I guess these multiple choice problems sort of give you some hints in that you better have an I somewhere in the answer, okay? If you look at the answer choices, there's I's there. And also, I have a feeling that there should be an 11 under that square root symbol. So, to simplify this, the square root of a negative is an imaginary number. So, I'm going to go ahead and put an I. Because of this red negative, that's why we have the red I. And then to simplify that square root of 275, well, that's that stuff we did on day 1. We rewrite 275 as a product using a perfect square. What are the perfect squares? 4, 9, 16, 25, 36. Well, which perfect square divides evenly into this? Let's see, 275. Here's just illustrating my thoughts. 4 doesn't divide into it. 9 doesn't. 16 doesn't. 25 divides evenly into 275. So I'll rewrite this as 25 times 11. And then, which one of those square roots can I simplify? The green one? Yeah, the square root of 25 I can write as a 5. And I can't do anything with that square root of 11, but it's customary to put the I between the number and the square root. So 5I square root of 11. Looking closely at these answer choices, they all start looking alike. The answer is A. I write an A in the blank. I don't put another number. Okay? Grading the letter, you write, oh, let me get rid of that calculator so you can see the letter I wrote in the blank. Okay? Now, problem 2. Problem 2. 6 minus the square root of a negative 108 all over 2. This is the stuff we were doing the first week of the semester. Okay, wait, I just remembered. I got to redo this. I don't want that thing there. Okay. To simplify this, I think I'll simplify the square root first. I think when I was doing these in homework, here's what I do. Put the arrow and simplify that square root the same way I did problem number 1. Well, will there be an I here? Well, yeah, because of the red negative, there'll be a red I. So let me see how I'm going to simplify that 108. What perfect square divides evenly into 108? So I'm thinking of those perfect squares. 4 does. 9 does also. 16 doesn't. 25 sure doesn't. What's the next perfect square? 36? Does 36 divide into that? Yeah. So 36 times 3 would give me of 108. Reducing that, I'd have a green 6. Then I'll go ahead and put the I square root of 3. And now I'll replace all of this circled square root with 6i square root of 3. So copying it or writing it all in one color. 6 minus this stuff all over 2. As a general rule of thumb, this software I use doesn't give you the intermediate answers. Okay, notice this isn't listed as an answer, so we're not finished yet. How do we simplify this? Well, when there's just one number in the bottom, you've got to separate it. Okay, that's what those little marks mean. The 6 over 2 we could write as 3. Then a minus. The 6 over 2, another 3. I square root of 3. Okay. And look closely at these answers. Okay, the multiple choice on your homework, you get a few guesses. Here on the test, this paper tells you only get one guess. I'm thinking it's C, isn't it? Is that it? 3 minus 3i square root of 3? Yeah. Okay. Now, let's do problem number 3. Problem 3. 8 minus 7i minus 2 plus 4i minus 2 plus 9i. Well, here, what are we doing? Well, we're combining, or we're subtracting complex numbers. So this minus in front, you got to distribute and then combine the like terms. So I'll just drop the first set of parentheses. And then when I start distributing the minus, I have a minus 2 and a minus 4i and another minus 2 and a minus 9i. And now combine the like terms. Well, the numbers that don't have an I on them, you combine those together. 8 minus 2 minus 4. That would be, 8 minus 2 minus 2. That would be a 4. So 8 minus 2 minus 2 is 4. Now we'll combine the I terms. Let's see, they're all negative, so I'm just going to say negative 7 plus a negative 4 plus a negative 9. Negative 7 plus a negative 4 is negative 11, plus a negative 9 is a negative 20. I don't subtract the 4 and the 20. At that point, those aren't like terms. So let me see. 4 minus 20i, that's C. Okay. If you have any questions, just call them out. Okay. I have to sort of go through this quickly. Why? Well, I want to get the whole thing done. Okay. So number 4 says find the product. 7 minus 2i times 5 plus 7i. Well, how do we do this one? We are going to FOIL it out. And then there's something about I squared. So let me just write up what I'm doing here. I'm going to FOIL. And then do y'all remember a rule about I squared? Yeah, did y'all hear that? Replace the I squared with negative 1. So starting to FOIL. Lift this up. Just like in the past, I'll put this paper here under document sharing as class notes. I'll also have the video of me working these problems on YouTube later today after class. It's a matter of how fast it takes to upload it. So let's see, we have a 35. Then is that a plus 49i? And a minus 10i? And then negative 2i times negative 7i. Is that a negative 14i squared? So replace the I squared with negative 1. All that's going to do is change this minus 14 to a plus 14. So you might just sort of mark out the I squared and change that sign on the 14. And then combine the like terms again. Let's see. 35 plus 14. Combining those. Is that going to be a 49? And what about the i's? 49i minus 10i. Is that a 39i? So 49 plus 39i. Notice how similar these answers look. 49 plus 39i, another, C. Okay. Number 5. Let's see, what's number 5? It says solve the equation by the square root property. X squared equals negative 169. Negative 169. Let's see. Odds are 3 to 1 that you better have a 13 in the answer, right? 3 of the 4 answer choices have a 13. If I were going to just guess randomly on this, which one would you not guess? I probably wouldn't guess A. It just looks too different from all the other ones, right? So let's see. What's that square root property? Well, basically you're taking the square root of both sides. When you take the square root over here, the square and square root just cancel. So drop the square on the left. And on the right, you take the positive and negative square root of that number. So how would I simplify that square root of negative 169? Well, because there's a negative under the square root, there is an I in your answer. And do I know the square root of 169? I should be punch it into our calculator. It's not really part of the multiplication tables. We always think of the multiplication tables as ending as 12 times 12. If it continued on to 13 times 13, that would give you 169. So the square root of 169 is a 13. Notice, the 13 is no longer under the square root. When you look at that calculator, it doesn't have a square root here. The square root of 169 is 13. Plus minus 13i. Is that going to be C? Oh, wow. If in doubt, guess C. I'm joking about that. And problem number... Are there any questions? Y'all caught up with me? I'm sort of going through this quickly. Those of you way over there, can you hear me? Okay. Another teacher told me that they found out that there's a microphone in the room, so I can use it, the microphone to record. Okay? It doesn't actually project my voice over there, unfortunately. But I can record it and then play it, and it'll project over there. But why would I do that? X squared equals 18. It's another square root property. So I do the same thing I did on number 5. Drop the square on the left. Take the positive and negative square root of the number on the right. Is there going to be an I in this answer? No, there's no negative under the square root. As if there's a negative under the square root symbol that you have an I. Okay. Oh, let's see. I don't even need to punch it into my calculator to figure out what perfect square divides evenly into 18. 9. Can I hear 9 times 2? So this would simplify to plus minus 3 square root of 2. Oh, wow. Let's see. D. Any questions on that? Okay. Problem number 7 is another one of these square root problems, but it just looks different from 5 and 6. 2x plus 3 squared equals 10. So that's problem number 7. Well, even though it looks different from 5 and 6, I think I said from 5 and 10, I meant from 5 and 6, you can still go through and do what we did here, dropping the square on the left, and take the positive and negative square root of the number on the right. Square root of 10 doesn't simplify. What are the only numbers that divide into it? 2 times 5, no perfect square. And you can sort of look, every one of the answer choices has a 10 in it. So, or square root of 10, I mean. So I wouldn't expect that we should get rid of that square root of 10 here. Well, what do I do now? Well, get the x by itself. Okay, we need it in the form x equals. So what would y'all do to get the x by itself? Would y'all move the 3? So we have a negative 3 plus minus square root of 10. And then do what to get the x by itself? Divide by 2, and I think we're finished. You can't simplify this at all. Theoretically, you could separate it, but you can't cancel anything. So we'll leave it like that. Negative 3 plus minus square root of 10 all over 2. Look closely, please. Negative 3 plus minus, I'm thinking this one's C also. Just because there seem to be more C's than anything else, it's just random letters, okay? Negative 3 plus minus root of 10 all over 2. By the way, sometimes I remember this time the student told me at the end of the semester, I never asked for excuses for making. He wanted to tell me why he did poorly. And he didn't know the answers to the review sheet. I was like, oh my gosh, you didn't ever look at the last page of the review sheet? That's where the answers are. A's, all those C's. And then 8 is a D. No, I've got ahead of myself. Okay, we've only done through C. So C, D, C, C, yeah. Okay, so I'm amazingly getting them right. So, any questions? So we're up to problem number 8. 20 short years will be finished. Okay? Amazing things that stand out in your head. As a child, I remember watching a show with these people in prison. This was back when there were only 3 channels to watch. And they were digging, this person, he was digging out. And there was a cynic there looking at the work he'd done, digging out of the prison. And he said, oh my gosh, great, 20 short years will be free men. And that line just stayed in my head all this time. 20 short years, I'll be finished with this.
And you're a motivational speaker.
I know I am a good motivational speaker. In my past life, that was what I was destined to be, was a motivational speaker. Okay, so problem number 3 says solve using the quadratic formula. If the instructions say use the quadratic formula, it won't factor. Okay, so just go straight to the quadratic formula. Let's see. This is an equation that has fractions in it, so we need to cancel out these denominators. If you have an x and an x squared, do y'all remember what I can multiply through by that'll cancel out both of these? Just x squared. Take the one with the bigger exponent. So I'm multiplying straight through by x squared. And right here I'm going to write it as x squared over 1 so you can see the canceling. And the same thing there. So I'll have just 2x squared here equals, now I'm going to cancel the bottom purple x with one of these green x's. I'm doing that cross canceling you can do with multiplying fractions. So I'm just going to mark out that exponent because I still have a green x here. So I have a minus 10, a purple minus 10, and a green x. And over here, the x squares both cancel. So we just have that purple minus 5. Now, this is a quadratic equation, so it doesn't matter whether you're factoring it or using the quadratic formula. You need to get a 0 on one side and then write it in standard form. I'm going to get a 0 over here on the right by moving the 10x to the left and this 5. So I'm adding 10x and I'm adding 5. I always like this first number to be positive. It'll work out easier if it's positive. So that's why I'm moving everything to the left. A plus 10x, a plus 5 equals 0. Now, a equals 2. B equals 10, C equals 5. I'll write down the quadratic formula. Negative B plus minus the square root of B squared minus 4AC all over 2A. In 2 days you'll want to have that memorized at least for a few minutes to write it down on your test once you get it. There's 3 formulas that you need to have memorized. The quadratic formula, and then the 2 we did the last time, midpoint formula and distance formula. Okay? Maybe it was a week ago we did those. Anyway, so maybe not. So plugging in here, in place of the B, I'm putting that black 10. So negative 10 plus minus the square root. The B squared and the 2A I either do in my head or with a calculator, but I don't show that as a step on the formula. The B squared, 10 times 10, that's 100. minus 4 times A times C. A is a black 2. C is a black 5. All over 2 times A. The 2 times A I'll do in my head. 2 times 2 is going to be a 4 on the bottom. Now, let me use my calculator to simplify what's underneath that square root. So I'm just punching all of this into my calculator. Let's see what we have. 100 minus 4 times 2 is 8 times 5 is 40. So 100 minus 40 is 60. So we have a square root of 60 here, which I'm pretty sure we're going to have to simplify. Why am I saying that? Well, looking at the answer choices, and there's nothing wrong with looking at the answer choices and taking that into consideration. You may as well take advantage of the fact that it's multiple choice, because you have to live with the disadvantage of multiple choice. What's the disadvantage? Sure it is. It's right or wrong. Okay? You can write all you want and stuff. Before I gave multiple choice tests, I remember students would fill up pages and pages, and I'd spend hours looking, trying to figure out what are they doing and stuff. I'll give them half credit and go on. Okay? But not anymore. It's either right or it's wrong. But if you look at the answer choices, 3 of them have a 15 under there. So odds are 3 to 1 that there's a 15 under the square root symbol. So let's see. Is 60 divisible by 15? Yeah, 4. And 4 is that perfect square. So I'm thinking of 60 as 4 times 15. And I'm reducing the blue 4 to just a blue 2. Square root of 15. So I simplified that square root. And now I'm going to replace all of this square root with 2 square root of 15. So we'd have, and I'm also going to make it all in one color at this point. A negative 10 plus minus 2 square root of 15 all over 4. And not listed as an answer choice. Okay, we are not finished. Well, for simplifying a fraction like that, you can break it up if you want, but that's going to get you 2 fractions. And the answer choices are all written as just one big fraction. So how do I simplify these? Well, look at the 3 numbers that aren't under the square root. 10, 2, and 4. What can I divide those by? 2. So just go straight through dividing each of these numbers by 2. Negative 10 over 2 is a negative 5. 2 over 2, that cancels just to give a square root of 15. 4 over 2, 2. So we have a negative 5 plus square root of 15 all over 2. Let me look at the answer choices. It is, is it D, negative 5 plus minus square root of 15 all over 2? Yeah. I hope that I'm illustrating that taking a multiple choice math test is different from taking a multiple choice, let's say, history test. With the multiple choice history test, you read the problem. Who was the first president of the United States? And then what do? You look and see, where is George Washington listed, A, B, C, or D? you write the answer. With the multiple choice math test, there's an extra step. You read the problem, work it out, then write the answer, or choose the answer. Okay? This isn't just you read the problem and just, there's a step of working it out. Okay? So, number 9 is another quadratic formula. This is the same review sheet I used whenever I'm just teaching the standalone college algebra, the short one, not the 3-hour one, but the 80-minute one, the one that doesn't also have intermediate algebra built into it. We're taking the exact same college algebra test, same review that a normal college algebra, or not normal, the short college algebra class takes.
Question, did you teach both?
This semester, y'all are my only face-to-face classes this semester. But normally, what do I teach? I teach some college algebra, trig, huh?
I said I've been recommending you to everybody.
Oh, well.
But there's some people that only need one class.
Oh, yeah. Well, if they already taken intermediate algebra, but I like this one better. If you must know the truth, this is the class I like to teach at this point. 4n squared. Okay, number 9 is another quadratic formula problem. 4n squared equals negative 10n minus 2. By the way, on my college algebra playlist, I've worked out all of this with in a different video with it starts at number 87, I think is where I set on the playlist. So, but today I'll have a new one. There's a spring 2020 Math 13-14 playlist where I'm just putting y'all stuff. Okay, it's the new stuff I'm recording right now. Another quadratic formula problem, number 9. We don't have to get rid of the fraction because there isn't a fraction, unlike number 8. So these are not really arranged from, hardest to easiest. Right, number 9 might be a little easier because you just go straight to getting a 0 on one side. I'm going to move the 10 in and the 2 over. So 4n squared. That'll be a plus 10n and a plus 2 equals 0. In the original video when I worked this problem out, I might have noticed something and done something that I'm not going to do this time. Looking at all 3 of these numbers, they're all divisible by 2. So if you just want to have smaller numbers, divide straight through by 2. But I'm not going to do that this time because usually that doesn't happen. Okay? Like if this green 2 had been a 3, you couldn't divide through by. But if you divided straight through by 2, it'll get you smaller numbers and you'll get the answer faster on this problem. But more than likely, that doesn't happen often. So I'm going to go straight to the quadratic formula, writing out a equals 2, b is 10. Ooh, why did I say a equals 2? That should be a equals 4. B equals 10, C equals 2. Write down the formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. So, negative, I'm plugging a green 10 in for the b, negative, this black negative, it's just from the formula, negative 10 plus minus the square root of b squared. That b squared I do in my head, 10 squared, It's 100. Minus 4 times A times C. A is a green 4. C is a green 2. All over 2 times A. 2 times 4. Is that going to be an 8 in the bottom? Whenever I'm using the quadratic formula, the next thing I do, once I plug in, is simplify the square root. So 4 times 4 is 16, times 2, 32. Punching in that denominator, we have 100. It's going to be 100 minus 32, isn't it? It's going to be a 68. Yes, 68. So we have a square root of 68 here, which we need to simplify. How do I know? Well, there's no 68 here. In fact, odds are 3 to 1 that what number's under that square root? 17. Really, either a 17 or a 33. Okay? I say 33 because, can y'all see that? 33. So let's see, 17. What, does 17 divide evenly into 68? Yeah, and it's that perfect square 4. So I think of 68 as 4 times 17, which reduces to 2 square root of 17. So at this point, replace all of the circled square root with 2 square root of 17. And let's see, negative 10. I'm writing it all now with just one color. Plus minus 2 square root of 17 all over 8. What do I need to do now to simplify that? Divide by 2. Divide the 3 numbers that aren't under the square root, the 10, 2, and 5, by 2. Heck, I think that works out similar to the one we just did. Negative 10 over 2. That'll be a negative 5, plus or minus. The 2 over 2, though, would just cancel and leave a 1, so just square root of 17. The 8 over 2 is 4. Okay. So negative 5 plus minus the square root of 17 all over 4. I think that is letter A. Negative 5 plus minus square root of 17 all over 4. Yeah. Answer choice A. Okay. Any questions there? We ready to move to the next page? Test will be 20 problems, and it fit onto just 2 pages rather than 3, so I did it front and back. Okay, so I'm going to hand you literally just 1 sheet of paper and then 5 sheets of blank paper. Okay, so you can write out on them. If you want to use notebook paper, well, I don't have notebook paper. I have this type of blank paper, the paper with no lines. Okay, so if you want to bring notebook paper to use, that's fine. Oh my gosh, 2 more quadratic formula problems. So problem number 10. Let me lift this up. We are doing problem number 10. Solve the quadratic equation using the quadratic formula. 3x squared equals negative 12x minus 2. I'm having to go through these quickly. This is a review. I'm not really teaching it as if you've never seen it before at this point. I think this is another one where I got to move everything over and get a 0 first, don't I? So I'd have a 3x squared plus 12x and plus 2. And I'll write out A, B, and C, and then I'll write down the quadratic formula. A equals 3, B is 12, C is 2, negative B plus minus square root of B squared minus 4AC all over 2A. The formula. Now let's start plugging in. Negative. In place of the B, I'm going to put a red 12. Plus minus the square root B squared. Punching into the calculator. 12 times 12, if you don't remember, it's 144. Minus 4 times A times C all over 2 times A, 2 times 3, is that a 6? What am I about to do? Well, simplify into that square root. Okay? So, do it either by hand or calculator. I'm not saying that I think the numbers are so big. If you're thinking, well, wait a minute, I don't need a calculator for this. Okay, it's just my thought process. 4 times 3 is 12, times 2 is 24. 144 minus 24 is 120, but that's what I'm doing. 144 minus 4 times 3 times 2. 120. Can I simplify square root of 120? Well, there's no 120 under a square root in any of the answers. So, I see 30's under the square root and 42. Which one should I try first to see if I can get a perfect square? Yeah, 120 divided by 30. I suspect there are people watching these videos just to laugh. Oh my God, there's a math professor, and to figure out 120 divided by 30, he's punching it into a calculator. No, I can do it in my head, but I can't show you my head. Okay? What I'm doing up here. That's just for illustration purposes. So, you think of this as 4 times 30, which we reduce to 2 square root of 30. Now, let me write it all with just one color. Replacing this big circled square root with 2 square root of 30. So, negative 12 plus minus 2 square root of 30 all over 6, which, surprise, surprise, what can we divide above and below by? Divide them by 2, we would get a negative 6 plus or minus square root of 30. 2 over 2 is just a 1. 6 over 2 is 3. So negative 6 plus or minus the square root of 30 all over 3. C. Any questions there? Oh, Looks like we have another, if you're thinking that, oh my gosh, he's actually sighing. He's the one doing the talking, yeah. I do catch myself doing that. Okay, number 11. 20 short years will be finished, okay? X squared plus 4x plus 40 equals 0. It says use the quadratic formula. Okay. Well, this one's already in the form that we need it in. There's a 0 on one side, so I don't have to move anything around. I'm just going to go straight through. A is 1, B is 4, C is 40. I'll write down the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. Now we'll start plugging in here. Negative b plus minus square root of b squared. See, I'll do that in my head. 4 times 4, 16. Minus 4 times a times c. The a is a 1. The c is a 40. All over 2 times a. I'll do that in my head also. 2 times 1 is a 2. Let's simplify underneath that square root. Okay. 4 times 1 times 40 is 160, so it looks like we have 16 minus 160. 4 times 1 times 40. But 144 is a perfect square, right? What's the square root of 144? 12. But if I try to take the square root of that, it's going to give me an error. Non-real answer. What is it trying to say that this is? It's an imaginary number. That square root of negative 144. The square root of 144 is 12, and then you got to put an I on it because of this little negative under the square root. Okay? So write it all as one color, in one color. Oh, I'll write it all in one color. And however you reduce it, it's up to you. There's 2 ways. You can divide everything by 2. Or if you want to separate it, either way, you're going to get the same answer. What would it be? A negative 2 plus minus. What number's in front of the I? 6i. Okay. Negative 2 plus minus 6i, that is answer A. Okay? If you're using the quadratic formula, your answers are either going to look like this, with the plus minus square root in it, or it's going to have some i's in it. If you just get whole numbers or fractions here, integers or fractions, oh, wait, let me lift this up. If you get something like that, then it could have been factored. Okay? If I were going to guess an answer on 11 without doing it, I sure wouldn't guess D. Why? Because that's an answer you would get if you were factoring. Okay? And the fact that I told you, if it says use the quadratic formula, that means it will not factor. Okay? any questions over this quadratic formula? Hopefully there's enough there to jog your memory. Again, there's 20 problems on the test, 25 on the review. So it's not exactly a one-to-one correspondence. That means, what did I do? The software I used to make the review sheet, I regenerate the problem so it changes the numbers on everything, and then I shuffle it, so it shuffles it up in a random order, and then I go through and basically delete 5 problems. Okay?
Can I ask for a favor? It's easy for you to put things online. Okay, so the quadratic equation formula, I know and memorize that. I wasn't here for the beginning of the class, and I did watch the videos, but can you put the 3 formulas that we do need to memorize specifically?
You know what? Why don't I write them right here?
That's a message.
Okay. So these are the 3 formulas you should memorize. First was that quadratic formula. Negative b plus minus square root of b squared minus 4ac all over 2a. That's the first one. And then the last 2 we did, my brain's processed it. It was last Wednesday, 5 days ago. We got the distance formula. D equals second x minus first x squared plus second y minus first y squared. With the distance and midpoint formulas, you have to have those 2 ordered pairs. And this is not x squared right here. All that's saying is second x minus first x, second y minus first y. Now, these little numbers that are lifted up high, those are exponents. Okay? These are just subscripts down here. Now, for the midpoint formula, that's the one that students generally think is easier, because all you do is average the x's. To average, you would take the 2x values, add them up, divide by 2. Take the 2y values, add them up, divide by 2. Okay? So, if you want to know what 3 formulas should you have memorized, there they are. Okay? And the last 2, the distance and midpoint, those are new formulas. By new, I mean we just did them on Wednesday. Okay? They're not new to the world of math. There's nothing in this course new to the world of math. Okay? Test purposes, if I don't have on there, use a quadratic formula, that means if you have a quadratic equation, it'll factor. Starting with number 12, it just says solve the equation. So they'll either be linear or quadratic, but if they're quadratic, it doesn't say use the formula on those. So that means they'll factor. So problem number 12, one of those rational equations. By that I mean there's fractions. So we need to cancel out those denominators. What should I multiply straight through by that'll cross-cancel those denominators? Let's see, not just an x wouldn't do it. It would do it here. But if I just multiplied by x here, I'd still have that 3. What am I hinting at poorly that you multiply through by here? 3x. You multiply it straight through by 3x. Now be careful. Even the number over here that doesn't have a variable or a fraction, you've got to multiply by 3x. So let's see, canceling. The black x and the green x cancel, leaving a 1 times 3, so just a 3. The plus I'm about to write is this plus right there, just carrying it down. Here the 3x cancels with that green 3x, so we just have a 2, 12x. I can go ahead and add 3 plus 2 is 5. Oh heck, how did this problem make it on there? After everything we've been doing, this one falls out pretty quickly, doesn't it? What do I need? This is just a linear equation. So divide by 12, get the x by itself. Did I hear divide by 12? Because that's right. So 5 over 12 is the answer for number 12. 5 over 12, so C. Let me write down problem 13 now. Are y'all caught up? Are there any questions? I'm just going as long as I can go. If you need to step out, then that's okay, it won't bother me. 1 minus 5 over x minus 36 over x squared equals 0. Heck, this one reminds me of a problem we did earlier. What do we have to do to get rid of these fractions? Multiply through by x squared. The one we did earlier, problem 8, that we had to multiply by x squared, it was a quadratic formula problem. This one doesn't say use the quadratic formula, so that means it'll factor. Okay? I don't want you to sit there trying to factor stuff and it not factor. So there the x squares cancel. Right here, the blue x cancels with one of the green x's. And all we're left with is 1x squared. So x squared minus, we have a blue 5 and a green x. I'll just write it 5x. I'm putting it all in the same color now. Minus 36 equals 0. It's a quadratic equation, not a linear equation. How do I know it's quadratic? Well, hopefully you're not thinking that. It's the x squared. Okay? So...
You said in a former video, that theoretically the 0 gets x squared, but it just turns into 0.
Huh?
Does the x squared...
Oh.
The 0 gets x squared?
Oh, yeah, the 0 also. What the heck? Thank you. Yeah, the 0 should be multiplied by x squared also. Okay? So, yeah, thanks. So, I'm going to do this one by factoring. This one factors pretty nicely. X and x. Second sign is minus, so that means we have a plus and a minus. Oh, numbers that multiply together to give 36. Well, there's 1 times 36, 2 times 18. Oh, wow, a lot of numbers multiply together to give 36. 3 times 12, 4 times 9, 6 times 6.
Did you have used the quadratic formula for this?
Yes. Oh, yeah, the quadratic formula will work anything. Okay? Which pair is going to work here? The 4 and 9. And how should I arrange my signs? A negative 4 and a plus 9? A negative and a plus. I'm thinking that would give me a positive 5x. I'm thinking you're ahead of me. Are you already at the answer? I think at this point it should be a plus 4 and a minus 9. Setting each one of these to 0. That's when we get a negative 4 and a positive 9. That's what I meant by you were ahead of me. No, a negative 4 and a positive 9. Look closely. A negative 4 and a positive 9. Oh, which one is it? Is it A? Negative 4 and positive 9. Yeah, it is A. Okay. Any questions there? Let's do number 14. Negative 5x squared minus 6 over x minus 4 equals a negative 15x over x minus 4 and a plus 6. Well, notice how I wrote it, spreading it out. What am I going to have to do on this one first? Okay, did y'all hear that? Multiply everything straight through by x minus 4. Even the 6 gets multiplied by x minus 4. Over here on the messy fractions, the x minus 4s will just cancel. And right here, you're multiplying every term. There's 3 terms. 2 fractions, and that's 6. Terms are separated with equal signs and addition or subtraction signs. So 1, 2, 3. Oh wow, it looks a mess, doesn't it? Let me write it, what we have here. A negative 5x squared and a minus 6. Then an equals a negative 15x. And I'm going to go ahead and distribute that 6 right there. So that would be a plus 6x and a minus 24. Well, is this a quadratic equation? Yeah, it has that x square in it. I think this is the first time today I'm doing what I'm about to do. In this quadratic equation, I like the x squared to be positive, so I'm moving everything over to the right. I'm getting the 0 over here on the left. I prefer that first sign to be positive, that first number there. So I have a 0 on the right, moving the 5x square over, just a 5x square. I'm also moving the 6 over, so that'll be adding 6. Negative 15x plus 6, is that a negative 9x? So I added those two. And then what am I about to write? Negative 18, is that what I heard? The negative 24 plus 6. This one's sort of messy. And This one, is it a linear equation or a quadratic equation? It's quadratic because there's an x squared. So factor it, use the quadratic formula. What am I going to do? I'm going to factor it. Why? I know it'll factor because it doesn't say use the quadratic formula. Numbers that multiply together to give 5. 1 and 5. Numbers that multiply together to give 18. There's 1 times 18, 2 times 9, and 3 times 6. So, 0. What do I know about the signs? Well, the second sign is minus, so a plus and a minus. Now, there's not a lot of possibilities for the 5. It's going to have 5x squared. It's going to have to be an x and a 5x. Okay? So, 1x, 5x. Oh gosh, what should I try for the 18? 1 and 18, 2 and 9, and 3 and 6. Well, 3 and 6 are going to be the ones that I would use. And once again, I want to point out, if you look at your answer choices here, if you were going to guess, certainly which one would you not guess? B. B is a quadratic formula. You only get that sort of answer if you're using the quadratic formula. If it'll factor, it should be fractions and integers. So looking at A, C, and D, do I see 1s and 18s, 2s and 9s, or 3s and 6s? Well, 3 and 6s. So that's why I'm going to pair it with the 3 and 6. Let's see. 3 and 6. Let me see. I'm going to do these little marks. We'd have a 15x for the inner and a 6x for the outer. Have I arranged these correctly? If I want a negative 9x, can I make this work out? Well, the bigger number would need to have the negative. So this negative would go in front of the 3 and a plus in front of the 6. Now, set each one of those factors to 0. So x minus 3 is 0. So isolate the x. So we have a 3 is one answer. Let's see, what would we do? We move the 6 over. So we have a negative 6. And divide by 5. So a negative 6 over 5. 3 and negative 6 over 5. I'm thinking this one's D. A 3 and a negative 6 over 5. Okay. Any questions here? Oh, wow. 15 and 16. I was very kind to y'all. These are the equations that have the radicals, and it looks like it's cube root ones, not the square root ones. Okay, so let me write down number 15. Cube root of 4x minus 7, then a plus 5 equals 3. Are there any questions? All caught up? Well, okay. number 15, cube root one. To solve an equation that has a radical, you've got to isolate the radical term. If there's two of them, you need to put one on each side. But here there's just one of them. So let's isolate this radical by, what would I do to isolate this radical? Yeah, subtract 5 from both sides. We'd have cube root of 4x minus 7 equals, is that a negative 2? 3 minus 5? Now let's cancel out that radical. What will I do to both sides to cancel out a cube root? Cube it. The left cancels easily. You just cancel the cube root and the cube. What about the right? Negative 2 cubed. Don't say negative 6. I heard negative 8. That's right. Negative 2 times negative 2 is a positive 4 times another negative 2, negative 8. Am I going to have to factor anything here? No, it's just a nice little linear equation. How do I know it's linear? Well, there's no exponent. So move the 7 over. Let's isolate the x. So we'd have 4x equals, is that a negative 1? And then divide by 4. So a negative 1 over 4. See. Oh wow, only 10 remaining after this. B. Any questions? I can't control the fonts on this software without actually getting into the coding and so forth. That's my way of saying it. This is an exponent, this 1/3. Okay? In my opinion, it's written too big, but I can't control that. Okay? It would be like me trying to control the exponent sizes on my lab. It's just a software that I use.
What problems were we working on where you couldn't have a negative on the right?
You couldn't have a negative. Absolute value equations.
Oh,
Okay? And I think there'll be some of those in the intermediate algebra quiz. It'll sort of pop up in a moment when we're doing cut points, but those like that are mainly intermediate algebra, so they're on the at-home quiz. Okay? Let's see, problem number 16. 3 minus 5x to the 1/3, and again, I'm sorry that these exponents look so big there, but that's part of the purpose of the review sheet, just to get familiar with what this software looks like. Equals to 0. That 1/3 exponent means cube root. So this one has 2 cube root symbols. So I'm rewriting it with a cube root. And now, since there's 2 of them, they both got to be isolated. So what would I do to isolate those cube roots? To put one on each side, I'm going to move this one over. So we have cube root of 3 minus 5x. Then it's equals cube root of 7 plus 7x. Now, oh wow. Note to self, next semester maybe make this problem harder. What would I do to both sides now? To cancel out the cube roots. Just cube it. It's going to look like all I'm doing is just writing it without the cube roots at this point. Just write the stuff that's there in black. 3 minus 5x equals 7 plus 7x. This is a linear equation. Pardon me. So, isolate the x. I think I'm going to do my little arrows. Oh gosh, how do y'all want to move it? Y'all want to put all the x's on the left? Okay, so I'm going to do this. I'm moving the 7x over there. I'm moving the 3 over to the right. So let's see, what are we going to have? A negative 5x. This is going to be a minus 7x. So negative 12x on the left. And what on the right? Move this up. The 4, 7 minus 3. Y'all following what I do with those arrows? So I don't have to write minus 3 on each side. And minus 7x on each side. Now, get the x by itself. Isolate the x by dividing both sides by negative 12. And that negative, or 4 over negative 12, that's not how the answer is listed. How is it written? It's written as a negative what? 1 over 3. If the smaller number's on top, it's going to be a fraction. If it had been 12 over 4, then you'd say 3. But 4 over 12, 1 over 3. Okay? Any questions there?
We had decided to move the negative 5x to the right and the other 7 to the left. You would have come out with
Oh yeah, you would have gone with you move this over here. That would give you you run a positive 12 over here, 12x. And a negative 4 over here. So basically you have a negative here and a positive there, still giving you a negative 1 over 3. Okay? So, y'all hear that question? If we moved it the other way around? Oh yeah, it doesn't matter which side you do. If you've done this over here, and that over there, then the 3 minus 7 would give you a negative 4 on the left. Adding the 5, that would give you a positive 12x. Divide by 12 to get the x by itself. And you're still getting a negative 1 over 3. Okay. It doesn't matter. Doesn't matter, it's up to you. Oh, but speaking of that, what's the answer? C? And, oh, look at it. Let me write an answer there. Okay. Starting with number 17, these are where it says solve an inequality and as a less than or greater than. There's a little, not a formula, but a process, steps that we go through. What are those called? What's the name of the process I'll use to solve 17 through 22? Everything that has a less than or a greater than in it. Cut points. Notice instructions don't say use the cut point method. It never said that in the homework. It just talks about solving the inequality. So you need to know, okay, if it's a if there's a less than or greater than in the problem, that's when we go through doing that cut point stuff. Okay? Problem number 17. Remember with cut points, you have the solution cut points and the denominator cut points. 17 and 18, there's no fraction, so no denominator cut point. On number 19, will there be a denominator cut point? Yes. Number 20, a denominator cut point? Yes, there's a fraction. Now 21 and 22, there's no fraction, but these are absolute value bars. It might be sort of hard to tell that. Okay? So, what are we going to be doing on those? Those are the ones you go equal, positive, equal, negative. How do you know which ones you go equal, positive, equal, negative? Those are the ones that have the absolute values on it. Okay? So let me write down problem number 17. Oh, I can't hear, huh?
I don't know if I think it's paused.
Oh, is it paused?
Yeah.
Oh, I wonder what happened. I wonder how long ago. No?
No.
Oh, well, now it's going. You know what? Maybe I should have not removed that little thing over here. Okay. But,
Sorry, it just looked like it wasn't.
well, I hope it isn't. Okay, well, then I have the old videos of me working this out. So, they're there, starting with 87 on the playlist. Problem 17. X squared plus 6x minus 7 greater than or equal to 0. If there's a less than or a greater than in it, that's when you start. Okay, solution cut points, denominator cut points, draw the number line. See, y'all remember that sequence of steps? I don't think I have any more of the little hints. I printed it out. It's also under document sharing. But for solution cut points, I put an equal sign. And that's a quadratic equation. So factor or use the quadratic formula. I'll always factor. X and X. This one sure factors pretty easily, isn't it? What are the only two numbers I can use for 7?
1 and 6.
1 and 7. 1 times 7. And second sign is minus. So that's a plus and a minus. How should I arrange it? A minus 1 and a plus 7. Then set each one of these factors to 0. And we get x equals 1. And x equals negative 7. Those are solution cut points. For the solution cut points, to decide between open and closed circles, you look up here. What's it going to be? Closed. There's no denominator cut points because there's no fraction. So I'll draw my number line. Label negative 7 and positive 1. Notice, make sure you're putting them in numerical order. Close circle. And you can test any number you want other than negative 7 and 1. If you wanted to test a negative 8, then you're testing this interval over here. If you wanted to use 2, 3, or 4, plug those in, you're testing this one. I'll normally test a 0, which is where? Well, between negative 7 and positive 1. There's nothing really special about 0. You can test any number you want other than the cut points. So I'm going to test 0, which means I'm testing this interval right here. I'll plug that into the original problem. 0 squared is 0. 6 times 0 is 0. Minus 7 is greater than or equal to 0. So what do we have on the left? A negative 7 is greater than or equal to 0? That's false. So cross it out. Others will show. We alternate. And then on your homework, you typed it in. The shaded intervals, not the crossed out ones. Parentheses, negative infinity, comma, negative 7, square bracket, union, bracket, 1 comma infinity. And this is what you would type in when doing these on your homework. But here's where there's sort of a difference between the homework and this little paper review sheet and paper test. Look at how the answers are written. This software is trying to get all of the answers in one row. If they start putting all of this as answers, it's not going to fit in just one row here. So reading through, what does it say? When it's written in, what's the first interval? Okay, what was the first interval? Negative infinity to negative 7. There. You write a B. Okay? And then if you're not sure what first means, it tells you, okay. The first interval is the one furthest to the left on the number line. If there's only one interval in the answer, then that's it. Okay? But they're saying use the first. It's asking for just the first interval. There's nothing special about that other than that's their little gimmick to make them all fit in just one row. Okay? Oh, wait, it's not B. Oh, thank you. I would have missed that one, would it? What should it have been? C. I got to look really closely. There's C. Number 18 is similar. Let me write it down. 18. X squared plus 7x is less than or equal to negative 12. Well, there's no denominator cut points, just solution. There's no fraction, so I'll write it with an equal sign and move that 12 over. So it will be a plus 12 equals 0. This one factors without too much trouble. X and X. Second sign is plus, so 2 of the first. 1 times 12, 2 times 6, or 3 times 4. Set each factor to 0 and isolate the x. So we get a negative 3 and a negative 4. Draw a number line, and this is where it gets tricky. Remember how this number line's set up? Oh, wait, I didn't ask y'all about open and closed circles. What should it be? Closed. Okay, there's an equal sign. Which number should be further to the left? Which one's closer to negative infinity? Am I going to put a negative 3 or a negative 4 right here? Negative 4. Negative 3. Those are the two numbers you cannot use as test points. So you could use something like a negative 5, negative 6, negative 7 if you want to test the first interval. I sure wouldn't decide to test this middle interval. What would you have to use? Something like negative 3.5? Where would 0 lie? That's the number I always want to use. Okay, 0 is between a negative and a positive always. That's how I decide where 0 lies. I remember one semester when a student asked me, why is 0 always moving? Right here, it's in the middle. But it depends on the numbers. 0 really isn't moving. It's just these numbers are changing. 0 is always between a negative and a positive. So that's why it's over here. 0 is certainly not between two negative numbers. We're testing 0. 0 squared is 0. 7 times 0 is 0. It's less than or equal to negative 12. Well, it's sure not equal. 0 is smaller than negative 12. That is false. Better to have $0 in your bank account than negative 12. So, false. False. So, this were on the homework, you would type in bracket, negative 4, comma, negative 3. Bracket. And that's the only interval. That's the one that's listed, and that's the one you choose. Okay? Don't help me on this one. Did I do it right? Unlike number 17. Okay? Any questions? I think we're down to 18 years. 18 short years, we'll be finished. Wow. Problem number 19. Oh, look. Let me write down number 19. What's different about 19? Well, it has a fraction. So we're going to have to do a little denominator cut point also here. It's problem number 19. X plus 21 over x plus 2 is less than 5. Again, how do I know when to use the cut point method? Well, if it says solve an inequality, if there's a less than or a greater than in it, then you use the cut point method. Find the solution cut points first by writing it with an equals. And to solve this equation, I'm going to write that 5 as 5 over 1 because I'm about to do what? To solve this one. Cross multiply. Okay? So we'd have is that a 5x plus 10 equals x plus 21? No factoring here, is it? It's a linear equation. So just move the stuff around. Let's see. I'll move the x and move the 10. By move, I mean I'm subtracting x. 5x minus 1x is 4x. 21 minus 10, 11. Divide both sides by 4. Now, I didn't ask this, so now's as good a time as any. Will it be an open circle or a closed circle? Open circle. Now, on this one, there is a denominator. So I'll find the denominator cut points by saying denominator cannot equal 0. Isolate the x. X can't be what? Negative 2. With denominator cut points, there's no choice. It's always what? Open or closed? Open. Open circles mean don't include those as answers. You would never want x to be -2 because then you'd have a 19 over 0. Try punching that into your calculator. It'll give you one of those errors. Now, let's see. I'll draw my number line. Oh, wow. Oh, wait, actually, this isn't hard to label, is it? Why do I say that? Well, the negative's always going to be on the left, isn't it, of the positive. So, -2 and an 11 over 4 is our cut points. You could test something like -3, -4, -5. If you wanted to test over here, oh gosh, maybe 3, 4, 5, 6, 7, 8, 9, something like that. That's not what I'm going to test. What am I going to test? 0, which lies where? In between a negative and a positive. I think I mentioned one day that at the end of the semester, when someone says, what did you get out of going to algebra class 6 hours a week for 16 weeks? You can say, I know how to find 0 on a real number line. And that's a joke. But, what? Where the heck does 0 lie? That's actually taking some work up here. 0, I'm testing, 0 plus 21 is 21. 0 plus 2 is 2. 21 divided by 2 is a 10.5. If you doubt it, maybe punch it into your calculator or do it by hand. Be 10 and a half, 21 over 2. Am I labeling this true or false? False. False. True. True. On your homework, what would you type in? You go parentheses, negative infinity, comma, -2, parentheses, union, parentheses, 11 over 4, comma, infinity. All it's asking for is the first one. So I'm looking for negative infinity to -2. I'm thinking that is C, negative infinity to -2. The other one, if I'm correct, isn't even listed there. 11 over 4 to infinity isn't even listed. There's a difference between A and D. They're both wrong. Oh. Okay, there's a negative on. Either way, both of those wrong. Okay. So I'll write C in. Okay. And now we move over to the last page. Let's do problem number 20. When I look at problem 20, I ask myself, okay, is this a cut point problem? Well, yeah, there's a less than or a greater than. Will there be a denominator cut point? Yeah. So here's number 20. X over x plus 1 greater than or equal to 2. So I find my solution cut point by writing an equal sign. And I'm going to write that 2 as 2 over 1, hinting that I'm about to do what? Cross multiply. So we'd have a, what is that, a 2x plus 2 equals 1x. And this equation is actually easier to solve than the one we had on problem 19, except the fact that there's not a number here with this x. It doesn't say plus or minus. Sometimes gives students trouble. But I'm still going to draw the arrows just like I did here to isolate the x. I move the x over there, and I move the 2 over here. Okay. If you want to think of that as x plus 0 on the right, okay. But you're still just isolating the x. So I think it's going to fall out pretty quickly now. 2x minus 1x is just x equals negative 2. Open or close circle. You look at the symbol, so a closed circle. Is there a denominator cut point? Well, yep. How do I know? Well, because there's a denominator. The denominator can't be 0. So x can't be negative 1. With denominator cut points, they are always what? Open. Oh, wow. Now this one's going to be, you got to be careful labeling them. We have a negative 2 and negative 1. Oh, wait. One of these is going to be a closed circle. Which one is closer to negative infinity? Right here, what am I labeling? Negative 2, so that should be a closed circle. And negative 1. Open. And where do I test? Well, I test 0. Where does 0 lie? Is it in the first interval, the middle, or the last? Right here, between a negative and a positive. So let's test 0. We have a 0 on top. A 0 plus 1 is just a 1. 0 divided by 1 is 0. True or false? 0 is greater than 2. False? Yeah, I think that's false. So, false. So your answer is just one interval, bracket negative 2, comma, negative 1, parentheses. Okay. Oh, let me lift this up. See it? And let me find it on the answers. Oh, I'm thinking it's answer choice A, isn't it? Negative 2 to negative 1. Okay. So now let's see. Any questions? The next problem, 21, both of them, 21, 22, still have less than and greater thans. So it's more cut point, but it also has absolute values. How do you solve those? How do you find those solution cut points? You're going to be going equal positive, equal negative. And it's sort of important that you be able to spot what do you do on this type of problem. Number 21, let me write it down. The absolute value of 2 minus x is greater than or equal to 9. There's no denominator cut points, but there are solution cut points. What numbers have absolute value equal to 9? Well, positive 9 and negative 9. So you go equal positive 9, equal negative 9. And isolate the x. I'm not going to move the 2's, because that would really isolate the x. There'd still be a negative in front of the x. Here's what I'm going to do. I'm going to move the x over, changing it to a positive x. And then over here, if I move the 9, 2 minus 9, Is that a -7? I'll do the same thing over here. I'll move the x, and I'll move the 9 by adding 9. So I would get a x on the right, and what number on the left? 11. Open or close circles? Closed. Draw a number line and test those intervals. So a -7, +11, close circles. Those are the two, -7, +11 are the two numbers I can't test. What number am I going to test? Well, a 0. Where would 0 lie? Yeah, in between a negative and a positive. So testing 0. 2 minus 0 would just give a 2. So the absolute value of 2 is 2. Is this another false one? Yeah. False. True. True. When we're doing these as homework, you would type in parentheses, negative infinity, comma -7, square bracket, union bracket, 11, infinity. But all they're interested in here is what was the first one? So, is that C? I think it is C. Right. 22 is another one like that one. Except I suspect there's going to be some fractions in our answer on 22. Oh, boy, these bubbles are getting annoying. -8x plus 9 is less than 6. Oh, I can't even see. I'm writing the problem down. Number 22. Absolute value of -8x plus 9 is less than 6. How do I start it? Solution cut points by going -8x plus 9 equals +6. -8x plus 9 is -6. Finding the cut points for these ones of the absolute value in it really aren't that difficult. Just remember to go equal positive, equal negative, isolate the x. Let's see, what would I do here? I would subtract the 9. So I have a -8x equals, is that a -3? Divide both sides by -8. So is that a 3/8? Over here, subtract the 9. Is that a -15? Divide both sides by -8. So that's going to be positive also. 15/8. Draw a number line. And how am I going to label these numbers? Open or closed circles? Open. There's no equal sign, so it's open circles. And it's, I guess, since they both have the same denominator, pretty easy to figure out which one's going to be the one to the left. 3 is smaller than 15. So this one's 3 over 8, 15 over 8. If we're going to test 0, where would 0 lie? It's sort of significant which interval you're testing, because if that's the one you start with and labeling true or false. So 0 is always between negative and positive. So testing 0 by plugging it into the original problem. Negative 8 times 0 is 0, plus 9 is just a 9. The absolute value of 9 is absolute value of 9 is 9. 9 less than 6, what am I going to label that? True or false? False. False. See, is it clear why I say it's important which interval you're testing? Because that's the one you start with. Okay, false. Then the other one, true, false, so forth. So, parentheses 3 over 8, comma, 15 over 8. Let's see. D. About 13 years ago, you asked me, 13 years back, you asked me, what formulas do we have to memorize? And I wrote them out. I think we're finally up to the other two, the distance and midpoint formulas. Okay? Any questions up to this point? In particular, how do you know when to do the cut point method? Use the cut points when there's a less than or a greater than. Okay? So, problem number 23 says, find the distance. Let me write these two down. 23. Here are my ordered pairs. 6, negative 1, 4, negative 7. Here's the distance formula. The square root x2, or second x, minus first x squared, second y, minus first y. Maybe I better go ahead and label the x and y's here. Remember, every ordered pair is x, y. So first x, first y, second x, second y. Be sure not to label them x1, x2. No. Ordered pairs are always x, y, x, y. So, plug it in here. Okay, second x minus first x. So, black 4. The red minus is from the formula. Black 6. Second y minus first y. So, negative 7 minus a negative 1. That would be a plus 1. You'll see the black negative changes this red minus to a plus. Let's hope we don't get a really big number. 4 minus 6 is a negative 2. So we have negative 2 squared plus Negative 7 plus 1, is that a 6 squared? So what are we going to wind up with under this square root? We have a 4 plus 36. Is it a 40 that we're going to get under there? Which is not listed as an answer. What does that mean? Well, it means we're not finished. Can we simplify square root of 40? Yeah, what perfect square divides into 40? Yeah. Oh, let me clear this. 40 divided by 4 is 10. So I can rewrite 40 as 4 times 10. And we get the square root of 4, which is 2. Square root of 10. 2 square root of 10. Okay. Which is, what should I say? A, B, C, or D? D? Okay. Number 24. I think I'll just work right here. Let's find the midpoint. Okay. Let's write the midpoint formula down. Midpoint formula, you're just averaging the x's. Just add the two x's together and divide by 2. Then add the two y's together and divide by 2. Just, I have a feeling that we're going to wind up with fractions in this answer. Add the two x's and divide by 2. You know what? I'm going to write the problem down bigger just because I can't see the typing hardly. It's a negative 3 comma negative 2 and a 4 negative 9. First x, first y. Second x, second y. So now plugging in. Remember, when you're doing these in the homework, you've got to make sure you put those parentheses. Well, here, putting the parentheses, whether you write them down or not, doesn't matter, does it? Okay, so you're going first x plus second x. You're adding the two x's and dividing by 2. Add the two y's and divide by 2. So let's see, what are we getting? A 1 over 2 and a negative 11 over 2. Any questions there? Do you see what I did there? So if the formula for the midpoint, you average the x's. What do I mean by average? Add them up, divide by 2. Isn't that how you average two numbers? So I'm averaging the two x's. I'm averaging the two y's. Make sure you're going xy, xy. Don't average these two numbers. Don't find yourself averaging the x and y. Okay? So which one is it? I am thinking it is it B? Only one left. And this one is just like a homework problem. Okay? To graph these, it says graph this equation by plotting points. Well, we're just going to plug in some numbers. You can't have any imaginary numbers, so it's not just randomly plugging in numbers. Make sure you're getting real numbers. But if I made an XY table, let's see, if I put like a 0 in, I'd wind up with a decimal number. Square root of 3. What if I put in a 1? 1 plus 3 is 4. What's the y value there? 2. So let's see, write 1. which graph has right 1, right 1. Have I done enough? I think I have, yeah. And so how did I decide on 1? Well, you can choose what you want to plug in. If you want to plug a 2 in, that'd give you a square root of 5, so use your calculator and get a decimal number and look and see. Okay? What you can't do is you can't plug in, say, a negative 4, because a negative 4 plus 3 would be a negative 1. And what's the square root of negative 1? It starts with an I. I, it's imaginary, that was a joke. You can't just plug a negative 4 in. You can't plug it negative 10 in. That would give you an imaginary number. Okay? So 3, 4, 2, 3, 4. What if I put a 6 in? If I put a 6 in for x, what would that give me? A square root of 9, which is 3. So there's another point. If you want to see which graph has right 6 up 3. Okay? But we've done it with just that one. It's up to you which numbers to plug in. Okay? Oh, so I forgot. Which one do I write there? The answer D. Okay. So, as I said at the beginning, the test is on Wednesday the 12th. A week from today, we'll do another lesson. The only difference is my brother will be here on that day. We will not have math class on the 19th. We'll both be gone on that day. If you have English class on the 19th, you have English class. It's not a holiday. It's only a holiday for math class. Okay? If you have any questions, I'll try to answer them. Otherwise, I will see y'all on Wednesday when you take your test. I dropped the lowest of the first 3 tests. So let's suppose you have a flat on the way up here. You don't have to panic too much. You just got to think, okay, that's going to be my dropped grade. I better make sure I don't have a flat the next 2 days. Okay? The next 2 tests. If you have any questions, I'll try to answer them. Otherwise, I'll see you on... Oh, wow, this is the longest video I've ever made. 2 hours and 2 minutes.